We talked about multiplication and division of rational expressions, so now I want to talk about addition and subtraction. In order to do that, I'm going to start with addition and subtraction of rational numbers. Okay, so for example, let's say that we had 3 over 4 plus 5 over 4. Now, the way that we would add these is we just add the numerators. We don't add the denominators. So in other words, this would be equal to 8 over 4. Okay, and the same thing is true for subtraction. So everything that we talk about for addition is the same thing for subtraction. So we're going to do it kind of interchangeably. If we have 8 over 4 minus 5 over 4, this is equal to 3 over 4. So all we're doing is we are subtracting the numerators, but not the denominators. So let's talk about what a rational expression is for a second, and that might help a little bit here with understanding how the addition and the subtraction work. Okay, so if we take, it's kind of like a side note. So if we take a rational expression, you're going to see rational expressions typically written as P over Q. So you saw that earlier when we started talking about rational expressions. You also saw it when we were talking about possible rational roots for polynomials. So here, if we have the rational expression P over Q, then the Q, essentially what we're doing is we're adding parts. This is a part where Q is the size of the piece. Imagine cutting a pizza pie. So the Q would represent the size of the slices, and the P would represent the number of slices. So if we have 3 over 4, that would be saying that we have 3 slices that are each 1/4 of a pizza pie. So here we have 3 slices, each 1/4. Then we have an additional 5 slices. So what does that mean? That means that we have a total of 8/4 of a pizza pie. And vice versa, if we started off with 8/4 of a pizza pie and we took out 5 of them, we're left with only 3/4 of a pizza pie. Now, what does this mean? This means that when we add and subtract rational numbers, we need to be adding and subtracting slices that are of the same size. Otherwise, it loses its meaning. Okay, so let's write that down. When adding or subtracting, so interchangeable, rational numbers or expressions, we need a common denominator. A common denominator meaning we need parts of equal sizes that we're adding and subtracting. Then we can just add and subtract the numerators. Sorry about that. Okay, so what do we mean by a common denominator? So the common denominator is the least common multiple of all of the denominators. So we've actually done this before when we were solving linear equations that had fractions in them, that had these rational numbers. We looked for these least common denominators, okay? So the common denominator is the least common multiple of the denominators. So let's take an example. And we'll do an example with rational numbers first, and then we'll move on to rational expressions. Okay. So for example, if we had 3 over 2 plus 7 over 4. Well, now we're taking half of a pizza pie, and we're adding it, we're taking 3 halves, which means we're looking at slices that are half of a pizza pie, and then we're also looking at slices that are a quarter of the size of a pizza pie. Okay, well, this really doesn't work. You can't add these two things when they're different sizes. We need to figure out how to take the slices and make them all the same size. That's what we're doing with the common denominators. We're taking these slices that are half the size of a pizza pie, and we're making them the same size as these, which are only a quarter of the size of a pizza pie. The way to do that is by using multiples, okay? So 4 is already a multiple of 2. How do we get to 4? Well, 2 times 2 is 4, okay? So what does that mean? That means that we could take this first fraction and we can multiply by 2 over 2. Okay, we're choosing the number 2 because 2 times 2 is 4. Notice that if we're multiplying the denominator by 2 in order to get the 4, we also have to multiply the numerator by 2, right? Because we can't change the value of the expression, so we need to multiply by 1. Anything times 1 is itself. Okay, so what does this mean that we have? Well, we know how to multiply rational numbers. We just multiply straight across. So this means that 3 slices that are each a half of a pizza pie, I keep saying pie, I'm sorry, tongue twister, I guess. 3 times 2 is 6. So we get 6 slices that are a quarter of the size of a pizza pie. And now we can add the 7 quarters because now we can add slices of the same size. which gives us 13/4 of a pizza pie. Okay? And we could do this a lot with rational numbers. You should have done this before, okay? Let's take this and apply it to algebraic expressions, okay? So let's just start with basics. Let's say that we do have a common denominator. So we're going to do a bunch of examples because we know that we learn from doing, okay? So let's say that our first one is x over x plus 3 plus 3 over x plus 3. Okay, well, the first thing that you want to do is you want to look at the denominators. The denominators already are common denominators. So we don't need to worry about finding this least common multiple because we already have a common denominator. So that common denominator is going to carry through. And remember, we're not adding these because we're not changing the size of the slices. We're just adding the number of slices. Okay, so the only thing that we add is the numerator. So the numerator is just x plus 3. These are not like terms, so we can't combine them. Always reduce your fractions. X plus 3 over x plus 3 is just 1. So we already had a common denominator. So we just add the numerators. And simplify our answer. Simplify is really important here. People forget to do that. X plus 3 over x plus 3 is 1. You should write it as 1. Okay. Let's take another example. So let's say that we have x over x squared minus y squared. And then we have minus y over x squared minus y squared. So remember, first thing that you check for is a common denominator. We have one here. Okay, if we have one, addition and subtraction is really straightforward. You subtract the numerators. So we have x minus y over x squared minus y squared. Well, the same thing is true here. Once you do the subtraction, you will always look to see, can we reduce the answer? And we can, because x squared minus y squared is a difference of squares. So you should always be looking out for this. When we talked about simplification of rational expressions, we said you should always look for a difference of squares. Okay, and x squared minus y squared is just x plus y times x minus y. And we know that the x minus y cancels. We get a 1 here. And keep in mind, I'll write that more clearly, that you do get a 1 in the numerator. If everything cancels and what you're left with is in the denominator, it stays there. So we're left with 1 over x plus y. Let's try another one. Let's say that we have 2x minus 3 over x minus 2 minus x minus 1 over x minus 2. Okay, so once again, first thing that you do is check the denominators. We have an x minus 2 and we have an x minus 2. The denominators are the same, so we don't have to do anything else there. We can just subtract. Okay, well, keep in mind when you subtract, this minus sign, it has to be distributed. So actually, let me write out. I'm going to write an extra step here. You can include it, but you don't have to. Essentially, what you're doing here is you're doing 2x minus 3 minus x minus 1. Okay, so you can write this out, or you can just go straight from the previous step, just showing that this negative sign gets distributed. Do not forget to distribute the negative sign. That's the biggest mistake that people make on these problems, is they forget when they're subtracting that that negative sign needs to be distributed. This x minus 1 is in invisible parentheses, so you are subtracting the whole x minus 1, not just the x. And what we get when we combine these is we actually get x minus 2, 2x minus x. And again, I'll write this extra step. Well, actually, this really is an extra. This you should include. This becomes minus x plus 1 over x minus 2. And what we get here is 2x minus x is x, and negative 3 plus 1 is negative 2. So we get an x minus 2 over x minus 2, which we know is 1. So always check for a common denominator first. And if you're subtracting, don't forget to distribute that minus sign to the second fraction. And you're only distributing it to the numerator. You wouldn't distribute it to the denominator because then you would have a negative 1 over negative 1, which is a positive 1. Okay, so don't forget to distribute. Biggest mistake that people make when subtracting. Okay, so let's keep going. Let's say that the denominators aren't the same. Okay, so I'm going to put this under a new set of examples. And we're just going to do a bunch of these. Just to give you some idea, I'm going to do 6 of them so that you could look ahead. So if you want to just watch the first 2 and then really work on the last 4 by yourself, feel free to do that. Or if you feel like you know how to do it, start trying now. And what you do, again, a reminder, once I write down the example, pause the video, try it yourself, and then restart the video to make sure that you got it correct. I really strongly encourage you to do this. Okay, so these are examples with different denominators. Again, we'll start off pretty simple, and then we'll get slightly more complicated. This does not get all that complicated. Okay. So let's say that we have 2x over x plus 3 plus 4 over x minus 5. Okay, we check our denominators and they're different. Now, you already knew that that was going to happen because I told you it was going to happen. So the question is, well, how do we find a common denominator? Okay, and in algebra, this is actually much easier than with rational numbers, because with rational numbers, you have to be really good at your number sense in terms of knowing what might be factors, what might be common multiples. Here, you don't have to do that. Here, you just need to ask yourself a really simple question. What does the other denominator have that this one doesn't? So let's start with the first fraction. What does the second denominator have that the first one doesn't? So the first one has an x plus 3, and remember that x plus 3 is in parentheses. It's this invisible parentheses. And you have to remember to treat it that way, because if you don't, then what you're going to do is you're going to say, well, the other one, it has a negative 5, and this one doesn't. No, that would be incorrect, because yes, that's true that a negative 5 is in the other denominator, but you can't say that it has an x, because the x is attached to a minus 5, okay? This is like one unit. So this denominator has the unit x plus 3. The other denominator has the unit x minus 5. So what does the second denominator have that the first one doesn't? X minus 5. Okay? And that's what you're going to multiply the first fraction by. X minus 5 over x minus 5, because you have to multiply by 1 so that you don't change the value of the fraction. So we're going to multiply this by x minus 5 over x minus 5. I encourage you to put it in parentheses so that you don't forget about distributing later on, and you'll see what I mean when we actually do it. Now we're going to ask ourselves the same question for the second denominator. So don't worry about this. We're saying, what does the first denominator have that the second one doesn't? So the first denominator has an x plus 3. The second one does not have that. So that's what we multiply by. X plus 3 over x plus 3. Okay, so let's write that down. So to find a common denominator, we ask, what does the other denominator have? That this one doesn't. Then we multiply the numerator and denominator. By that, we call it an expression. Okay, so we multiply the numerator and denominator by x minus 5. Okay. Why do we do that? Because we don't want to change any values. Okay. In other words, anything times 1 is equal to itself. Okay. So what do we do from here? Well, from here, we're going to distribute. You do not have to multiply out the denominators. In fact, I would strongly encourage you not to. Okay? So only multiply the numerators. So 2x times x minus 5 gives us 2x squared minus 10x over, leave it as x minus 5 times x plus 3 plus 4x plus 12 over x minus 5, x plus 3. So here we distributed. In the numerators. In the denominators, we just left them as being multiplied. You'll see why in a minute. Okay? Okay, so now we can add the numerators. So 2x squared. And then we have a negative 10x. Well, maybe what I'm going to do is I'm going to actually, you do not need to write this step, but I'm going to put it in here. You can skip this. You can go straight to adding. Okay. So we added the numerators. Now we're going to combine like terms. So negative 10x plus 4x is negative 6x. I'm going to put this in. I'm rewriting exactly the same thing. I'm just doing it in blue, just so that you see that my annotations are in a different color. This is add. Okay, so from here, we just combined like terms. Okay, the reason why we leave the denominator as it is, we don't multiply it, is that we want to make sure that we can't reduce the fraction, okay? So what we would do is we would factor the numerator, and it turns out that the most that we can do here is we could pull out a 2. And if we pull out a 2, we get x squared minus 3x plus 6. And then this is over x minus 5x plus 3. Okay, so we're factoring the numerator, and we're doing it with the purpose of determining if we can reduce. And x squared minus 3x plus 6, that's not factorable. So we can't reduce this fraction any further. Okay, this is our final answer here. Okay, so let's just summarize some of the things that we said. Okay. It's a 4-part process. So what you're doing is you're starting off by looking, can we find a common denominator? So on occasion, you can skip this first step, right? Because in the first 3 examples that we did, we already had a common denominator. The next step is to distribute. What does this mean? This means that you're rewriting the fractions with your common denominator. So if you're finding the common denominator, that's what we did when we were multiplying by x minus 5 over x minus 5 and x plus 3 over x plus 3. Once we've done that, we add the numerators. And then we're just checking to make sure that we can't reduce the fraction. Your denominator is already factored. So you only have to factor the numerator. Okay, so let's do a few more examples. And one thing that I will mention, which we'll get to by example 5, is that sometimes you may have to factor the numerator. Sometimes you may be reducing the fractions before you even begin, okay? And you're going to know when that happens because you're going to see something that's factorable from the very beginning. Okay, so like 2x minus 3 is not factorable, but we'll get into that in a few minutes. Okay, let's take the second example. Let's say that we have x plus 1 over x plus 6 times x minus 2. And we're going to add that to x plus 3 over x plus 6 times x minus 1. Okay, so we're going to repeat that question that we asked in the last one. For each of these expressions, we're going to say, what does the other denominator have that this one doesn't? Well, the other denominator has an x plus 6, but this one already has an x plus 6. So we don't need to worry about that. The other denominator has an x minus 1. This one doesn't. So that's what we're multiplying by. So we're going to multiply this first fraction by x minus 1 over x minus 1. Because the other denominator has an x minus 1. Now we're going to do the same thing for this one. What does the other denominator have that this one doesn't? Well, the other denominator has an x plus 6, which we already said this one has. The other denominator also has an x minus 2. This one does not have an x minus 2. So we're going to multiply. Okay, so now we found our common denominator. This is it. The next thing that we want to do is we want to multiply. So you can do this in 2 steps, okay? You can write it as 2 separate fractions and then add, or you can add the numerators and then write as 2 separate fractions. I'll explain what I mean in a second, okay? I'm going to multiply right now, and I'm going to write it as 2 separate fractions. So what we're doing is we're doing x minus 1 times x plus 1. That gives us x squared minus 1. And then what's our denominator? Well, I see an x minus 1 times x plus 6 times x minus 2. Now we're going to do the same thing for the other one. So x plus 3 times x minus 2 is x squared. And then plus 3x minus 2x plus 3x minus 2x is plus x minus 6. And again, x minus 1 times x plus 6 times x minus 2. And if you don't get the same thing, then you made a mistake in what you were multiplying by. Okay, so I'll just put this off to the side for anybody who just wasn't sure how we got this, but x minus 1 times x plus 1 is x squared minus 1. And x plus 3 times x minus 2, that's the x squared plus x minus 6. Okay, and this is what I mean by skipping a step. What you could have done is now I'm going to add like terms. What you could have done is you could have written this as one fraction, x squared minus 1 plus x squared plus x minus 6 over this denominator 1. So write it as one fraction instead of these 2 fractions and then adding. The reason why I do it as 2 is so that it's very clear where I'm getting these things from. Okay, it's not where I got the x squared minus 1, I multiplied the numerators. Where we got the x squared plus x minus 6, I multiplied these 2 numerators. Okay, as opposed to my just writing it as one fraction, I'm not going to see necessarily where I made a mistake if I did. Okay. So now I'm going to combine my terms. X squared plus x squared is 2x squared. Then we have a plus x here. Then we have a negative 1 minus 6, which is negative 7. Okay, so in other words, you have a choice in the step that you write. You can either write it like this, or you can write it as x squared minus 1 plus x squared plus x minus 6 over, and then this denominator just once. Okay, you have a choice. If you don't understand your choice that confused you, just do it this way. It's fine. This is probably the neater way to do it. Okay. And this is not factorable, so this is our final answer. Okay, so once again, from here to here, we found a common denominator. And multiplied the numerators. From here to here, we added the numerators. Notice I never multiplied the denominators. You don't have to. And then this is not factorable. I'll add in the numerator. So we can't reduce. Okay, Let's do another one. Three over x plus 1 plus 4 over x squared minus 1. Okay. This is the case where you're going to see this happening over and over. This adds one step to our process. If you can factor, factor first. Okay? So if you can factor, you should factor first. There are two reasons for this. The first reason is the reason that you'll see in this example and in the next one. In the last two problems, you'll see the second reason. So the first reason is that if we don't factor first, sometimes we get a common denominator, but it's not the least common denominator. And the problem with that is that at the very end, when we say, okay, well, we have to check, we have to factor the numerator to see if we can reduce. Sometimes if we don't choose the lowest common denominator, then this gets much harder to factor, okay? Because maybe it'll wind up as a cubic, okay? We know how to factor quadratics. We don't know how to factor cubics, particularly if we can't factor by grouping. So you want to factor so that you can make sure that you get the lowest common denominator. And you'll see what I mean. X squared minus 1 is a difference of squares. So what this is equal to is actually 3 over x plus 1 plus 4 over x plus 1 x minus 1. So notice now when we find the common denominator and we say, what does the other one have that this one doesn't? The other one has an x plus 1, but this one already has that. So now we only have to multiply by x minus 1 instead of multiplying by x squared minus 1, which makes a difference, okay? It will make a difference. So we only have to multiply the other denominator by x minus 1 over x minus 1, because the other denominator has an x plus 1, but this one has that. Here's another difference. When we do the next one, when we look at this one and we say, what does the other one have that this one doesn't? When we factor it, we can say, well, the other one has an x plus 1, and it's already here. We don't have to multiply by anything. Whereas if we looked at the denominator unfactored, then we would be saying, okay, well, we have to multiply by x plus 1 over x plus 1. Okay, so we would be doing extra work. So two reasons. One, to get the least common denominator so that we're not doing extra work. And two, so that at the very end, we don't always have to reduce. Okay, if you don't find the lowest common denominator, you will have to reduce. Okay, so what do we do from here? Well, again, you can do this, you can change the way that you write this middle step. You can write it as one fraction, or you can write it as 2. I'm going to write it as as 2. So in other words, first, distribute the numerators. Keep it as 2 separate fractions and distribute the numerators. And then add. So 3x minus 3 plus 4 is 3x plus 1. Okay. So we didn't have to multiply by anything. Because this denominator already has x plus 1. And 3x plus 1 is not factorable, so this is our final answer. Nothing can be canceled. Okay, let's take another example. So notice by factoring, we actually made this problem shorter for ourselves. And we didn't have to worry about having quadratics at the end, because if you had multiplied this by x squared minus 1, you would have wound up with a quadratic up here, which you would have had to factor, and it would have been factorable, and it would have been a pain, okay? Because you would have had to, this has to be factored eventually anyway. So you may as well do it in the beginning. Okay, let's take the next one. So this is just really practicing finding the lowest common denominator in this one. I'm not worried about putting factoring into all of these because you know how to factor at this point. So we'll practice factoring in the next two, but we don't have to practice factoring for all of them, okay? I want you to see how to find the lowest common denominator. So I want you to practice using this one. So again, what you're asking yourself is, so first of all, it's factored already, so we don't have to factor. Second, we're asking ourselves, what does this other denominator have that this one doesn't? Well, the other denominator has an x plus 1. This one doesn't. So we know that we're going to be multiplying definitely by x plus 1. The question is, do we multiply by anything else? So the second thing that it has is an x plus 9, but this one already has an x plus 9, so we don't have to multiply by anything else. So we're done there. Now we're going to ask ourselves the same question about the other one. Well, the other one has an x plus 8. This one does not. So we're going to be multiplying by x plus 8, definitely. Then the other one has an x plus 9, but we know that that's here already. So we don't have to multiply by that. If you did not find the least common denominator, you would be multiplying cubics here, okay? I can tell you now, in this class, I will not give you cubics to multiply on your exams, okay? I will not ask you to do that. Okay, so here, notice this is subtraction, okay? So here, what comes next is multiplying our numerators. So what do we get? Well, x plus 1 times x plus 6 is x squared plus 7x plus 6. And we have over x plus 1 times x plus 8 times x plus 9. And then minus, and we have x squared plus x minus 56 over x plus 1 times x plus 9 times x plus 8. Now be aware of what you're doing here. Remember, this is subtraction, so we have to distribute the minus sign. So I'm going to put in an extra step for everybody. You can theoretically skip this step and just combine like terms, but when you combine like terms, if you skip the step that I'm giving you right now, then you have to make sure that when you combine them, you still are distributing, okay? So this would give us x squared plus 7x plus 6 minus x squared minus x plus 56 over x plus 1 times x plus 9 times x plus 8. Okay, and now if we combine like terms, the x squares will cancel actually. And we get 7x minus x, which is 6x. And then we have plus 6 plus 56, which is plus 62. Over x plus 1, x plus 8, x plus 9. And this is our final answer, because when we pull out, we can pull out from the numerator, we could pull out a 2. Okay, there's no point in doing that because we know if we pull out a 2, we're not going to get one of these 3. And the only purpose of factoring is to reduce. So even though 6x plus 62 can be factored into 2 times, in parentheses, 3x plus 31, 3x plus 31 can't be canceled with anything. So we don't have to bother doing that. Okay. Let's take the next one. So in the next one, you'll see why factoring at the beginning is necessary. So let's say that we have x squared plus 6x plus 8 over x squared plus 7x plus 12 minus x squared plus 3x minus 54 over x squared minus x minus 30. I'm sorry, I didn't mean to cover that up. Okay, so this is a great example of why factoring first is really important. This is really complex, right? And I wouldn't call it, that you can't do it. You can absolutely do it. The only thing is, why would you make something harder than it is? Okay, and you would be making something harder than it is if you did not factor. So what you want to do here is you want to factor first. And when you factor, x squared plus 6x plus 8 factors to x plus 4 times x plus 2. You have to factor the denominator. The denominator factors to x plus 4 times x plus 3. And if we do the other side, x squared plus 3x minus 54 is x plus 9 over x minus 6. And x squared minus x minus 30 is x plus 5 over x minus 6. So notice what happens. In the first fraction, x plus 4 cancels. In the second fraction, x minus 6 cancels. So what you really have is something much simpler. What you're really adding are the fractions x plus 2 over x minus 3, or subtracting, and the fraction x plus 9 over x plus 5. Notice that is much, much, much simpler, right? It is a much simpler fraction to be working with. So that's one of the reasons why we want to factor first, because we might wind up with much simpler fractions than we start off with. Because now this is just 2 linears. We go through, we find the least common denominator. So we say, okay, what do we multiply the first fraction by? Well, what is the second denominator half that the first one doesn't. Second denominator has x plus 5. So we're going to be multiplying by x plus 5 times x plus 5. X plus 5 over x plus 5. What does the first denominator have that the second one doesn't? X plus 3. So we're multiplying by x plus 3 over x plus 3. Okay, so what do we have here? Well, first fraction, when we multiply, we get x squared plus 7x plus 10 times x plus 5, x plus 3. And then minus in the second fraction, we get x squared plus 12x plus 27 over x plus 5 times x plus 3. And then don't forget what we have to do. This minus sign needs to be distributed to everything. So, and actually, because you're subtracting that whole fraction, remember there are invisible parentheses around that numerator. So what do we get? X squared plus 7x plus 10 minus x squared minus 12x minus 27 times x plus, over x plus 5 times x plus 3. So the x squares cancel. 7x minus 12x is negative 5x. And 10x minus 27 is negative 17. And this is our final answer. So we factor. We found the common denominator. We multiplied the numerators. We distributed the minus sign. Combined like terms. And this can't be reduced. Okay, last one. X squared plus 5x plus 6 over 2x squared plus 4x minus 6. This time we'll do adding. Plus x squared plus 6x minus 16 over x squared minus 3x plus 2. Okay, and a quick note here. The idea is to factor first. Notice this is a quadratic. Okay, you can factor this quadratic however you want. Okay, but if every single term has something in common, I do encourage you to multiply, to pull it out first and say, okay, well then this is 2 times x squared plus 2x minus 3. You're going to have to pull out a 2 anyway, even after you factor. You're going to have to pull out a 2 eventually. So you may as well pull it out first because that's going to make it easier for you to factor the quadratic. Okay, so look for something that every term has in common. In these other three, there's nothing that every term has in common. Okay, so what does this equal? Well, when we factor, we get x plus 3 times x plus 2 over 2, and then x squared plus 2x minus 3 factors to x plus 3 times x minus 1. And then in the second one, we have x plus 8 times x minus 2. And then we have x minus 2 times x minus 1. And notice what happens. In the first, x plus 3 cancels. In the second, x minus 2 cancels. So what does that mean? We actually have two very simple rational expressions. We have x plus 2 over 2 times x minus 1 plus x plus 8 over x minus 1. And now we're finding a common denominator. So notice this is much simpler than what we started with. What does the other denominator have that this one doesn't? Nothing. The other denominator has an x minus 1. This one has an x minus 1. This doesn't get multiplied by anything. Now we go to this second fraction. What does the other one have that this one doesn't? A 2. That's it. It has a 2 and an x minus 1. The x minus 1 is already here. So we multiply by 2 over 2. What does that mean? It means we have these two fractions. The first one doesn't change. It's just x plus 1 times 2. X plus 2 over 2 times x minus 1. And then that 2 here has to be distributed. 2x plus 16. Okay, so now we add 3x plus 18 over 2 times x minus 1. Okay, and you can factor this numerator, right? Both things are divisible by 3, so you can pull out a 3. The thing is that all you'll get is an x plus 6. You get 3 times x plus 6, and you can't cancel anything. So if you're good with your numbers and you see that right away, you don't have to factor it. And you're done. So one note that I'm going to make, and I'm going to box it off because it's important. When you cancel, you can only cancel before finding the common denominator, okay? Or at the very end when you're reducing your final answer. I get a lot of people who cancel here because they get confused. They go through all of this and then they cancel over here the x plus 5s. That is undoing the work that you just did. You just multiply by x plus 5 so you have a common denominator. You're going to know that you did something wrong because if we canceled the x plus 5, then we would be going back to exactly where we were before, where in this denominator we have an x plus 3, and in this one we have an x plus 5, and they're no longer common denominators. Okay, so in terms of canceling, it can only be done before finding the common denominator or at the very end when you're reducing your final answer. And just to be clear, I'll say before you start finding the common denominator. So you can't even It's before you even think about what the other fraction, what the other denominator has. Okay, and in the next video, we're going to be combining everything that we know about operations on rational expressions. But that is it for now.